So good morning, my dear students. Uh, Today, we will going to solve the problems on beta angle problem. Till now what we discussed in the projection of planes. So we discussed the lamina resting on HP, the lamina resting on VP, either resting on H or resting on corner. And also in the last class we discussed when the front view, when the lamina looks like a, or when the isosceles triangle looks like a equilateral triangle, or square looking like a rectangle, or rectangle looking like a square. So these are all the typical type of problems what we saw. But we have another one most important type of problem in planes is beta angle problem. See, what is this beta angle, and when we need to consider this beta angle for drawing the projections. Okay, so because in the problem statement they don't specify. In the problem they don't specify you have to solve this problem by using beta angle. But you should be in a position to know whether we have to use beta angle for this problem or not to use the beta angle. So till now we have not discussed the concept of beta angle. Okay? So therefore it is very important for a student to know whether this problem requires the beta angle to be taken or not. So this is a very important decision you have to make while you are solving the problem, especially in planes as well as in the solids. Okay. So in today's class, let us discuss this beta angle and what is this beta angle actually, and how on when to take this beta angle and how to take this beta angle in a projection. This is what we are going to do. See, generally what happens, so what the problems you solve in so especially when a median of a triangle. So please, if you want to have, can make a note of these things. So everybody, please, I request everybody to note down these things. So when we consider, when we need to have the beta angle, see what happens when a lamina, when you just rest it on HP or rest it on VP, either on H or on a corner, and if it is being inclined with respect to any one of the reference planes. So if it is, if the surface of the lamina is inclined to HP, okay, or the surface of the lamina is inclined to VP, whatever it might be. So in the second position, when you satisfy the condition of the lamina is inclined to HP or inclined to VP at some angle. So what happens? The shape of the lamina or the size of the lamina will be diminished. So this is what we were talking in the last class. So when a square looking like a rectangle, when an isosceles triangle looking like an equilateral triangle. So how this isosceles triangle looks like an equilateral triangle, or a square looks like a rectangle, or when a rectangle looks like a square. All these things will happen when the lamina has been inclined with respect to any one of the reference planes. So in the second position, so whatever, whether it is a top view or a front view, so what we are going to get, it is of a diminished shape, or what we call it as, it is not an apparent shape and size of the lamina. So in such cases, so what we get, either it is a median or a diagonal or the perpendicular bisector in the case of the pentagon. Once it is being inclined, so its length will also get shorter. So now what we do in the third position is the same position. If it is inclined to HP or VP, in the same position we will go to tilt the lamina with respect to VP or with respect to HP, depending upon the initial position what we have placed. So the same, that is what it is, whether it is inclined to HP in the second position or with respect to inclined with respect to VP. In the same position, we will go to tilt the lamina in such a way that the diagonal or the perpendicular bisector or the median in the case of a triangle. So it is being inclined to VP to some angle and inclined to HP at some angle. So what we have doing here is, so when already it is the length of the median or a rectangle, median or a diagonal or a perpendicular bisector is already been shortened or it is been decreased, And in the same position, if you just incline with respect to, or you are inclining with respect to other reference plane, definitely the angle of inclination with respect to the reference plane in the third position will not be exactly as that of the angle what is supposed to incline. It will be inclined with respect to that position, with respect to the reference plane with a different angle. So in the sense, if you say the the median of a triangle, the median of a triangle is inclined to HP at 45 degrees and inclined to VP at 30 degrees. This is the problem if they say. Okay, so what you do, you are going to place it on HP, you are going to incline with respect to HP at 45 degrees in the second position, and in the same position, in the third position, what you do, the same median is said to be inclined to VP at 30 degrees. So in such cases, in the third position, the lamina is looking, it is inclined to VP with a different angle, the angle more than that of the angle what it is being given in the problem. So that apparent angle, what we call it as the beta angle. Okay. So now, when to consider, this is what we call it as beta angle. Now we have to determine this beta angle and how to use this beta angle or how to determine this beta angle by projection. So this is what the challenging task in the coming up problem. So therefore, the beta angle in the sense, so the angle which is being inclined with respect to the reference planes, which are more than that of the actual what it is being inclined. So that is what we call it as the beta angle. So these beta angles are need to be taken or need to be considered only certain conditions, not all the conditions. So when we supposed to consider the beta angle is when the median of a triangle, please make a note of this, when a median of a triangle, when the diagonal of a square or the perpendicular bisector of a pentagon or a diagonal of a hexagon and the diameter of a circular lamina, if it is inclined to both HP and VP. If any problem statement is to get the median of a triangle, the diagonal of a square, perpendicular bisector of a pentagon, diagonal of a hexagon, and the diameter of the circular lamina, if it is inclined to both HP and VP, then we need to consider or we need to solve those problems by using beta. Okay, and also sometimes, so previously we solved some problems. So what happens, they will going to give it is appears to be inclined. Appears to be inclined. If the word appears, please make a note of this. This is very, very important. So because in the problem statement, they don't specify whether we have to use beta angle or we don't want to use beta angle. Okay. So you should be in a position to know when to use beta angle and when not to use beta angle. Because both the problems looks very similar. Sometimes we need to consider beta angle, sometimes we need not to consider the beta angle. That decision has to be made. So how do you make it? Is very simple. It is a blind way of just deciding, making the decision here. So please look at in the problem statement, if any one of this median or a diagonal or a diameter or perpendicular bisector, if it is appears to be inclined, if they are given in the third position. In the third position condition, if they are given appears to be inclined, appears to be, the word appears is present in the problem statement, don't take beta. Please make a note of this. If the word appears is present in the problem statement with respect to the third position condition, please don't consider the beta angle. If the word is not there, please make a note that if the word appears is not there in the problem statement, then we have to solve that problem by taking beta angle. I hope everybody is clear. Okay. So please, if you have any clarification before I start, so you can ask me. Anybody? Please unmute yourself. So this is the condition. So means, so please remember, I will just repeat once again. So when to consider beta angle, when the median of a triangle, a diagonal of a square lamina, the perpendicular bisector of a pentagon, a diagonal of a hexagon, and the diameter of a circular lamina, it is inclined to both HP and VP. If the problem statement is good, if it is inclined to both HP and VP, so then we need to consider the beta angle. Then, if the word does not appears in the statement, problem statement, then we need to consider the beta angle. If the word does not appears, if the word does not appears in the problem statement, then we need to consider the beta angle and we need to solve. If the appears word is there, please don't consider the beta angle. Directly how we are solved one or two problems we solved in the pentagon and hexagon also. So directly you can solve those. Okay. I will take one problem now on a square lamina and we will go into solve this. And one important thing is when you have a square lamina or hexagonal lamina, so when we want to get a diagonal or a diagonal of a square or a diagonal of a hexagon, so if they are given, so the initial position we have to start with the corner. Please remember this. So why? Because so when they both square as well as the hexagon, when they rest it on the corner, then only you will going to get the true length of the diagram. Okay, so therefore be careful while you are resting it on, because in the square and hexagon they don't specify. They will say the diagonal of a square, the diagonal of a hexagon is inclined to HP, inclined to VP, like that they will go to VP. So be careful. Please make sure that you are resting either a square or a hexagon. Square or a hexagon. So you will go to rest it on the corner and you have to stop. This is a must condition, mandatory condition you are supposed to follow. Yeah? Let's take one problem now and we will go to solve. Let us take a square plate of 30 millimeter sides, 30 millimeter sides rests on HP, such that one of the diagonals is inclined at 30 degrees to HP, 30 degrees to HP and 45 degrees to VP. 30 degrees to HP and 45 degrees to VP. Draw its projections. Draw its projections. So this is a typical examination problem statement here. A square plate of 30 millimeter side rests on HP. See, look at the statement here. It is resting on HP. He has not given either it is resting on the edge or resting on the corner. Okay, so this is a typical, you should be very careful while you are solving the problems when you get a beta angle. Okay, especially square and hexagon. So please remember, a square or a hexagon, if the diagonals are given inclination, then you have to solve that problem only by just resting it on the corner only. Okay, resting it on the corner, because only in the corner only you can get the true length of the diagonal. Therefore, we are going to start the initial position with resting on the corner. Either rest it on the VP or rest it on the HP, not an issue. But it should rest it on the corner, especially for both square as well as for the hexagon. Okay. So in this problem, if you look at here, a 30 millimeter side square resting on HP such that one of the diagonals is inclined at 30 degrees to HP and 45 degrees to VP. Look at here. One of the diagonals. So the condition here is here. The diagonal of a square is inclined to both HP and VP. So now the concept of beta angle will come into the picture, and also the word appears is not. If they are given, it is inclined to HP at 30 degrees and appears to be inclined to VP at 45 degrees. If the statement like that, if the appears word is there, then not necessary to take the beta angle. But when you look at this problem statement here, so So the word appears is not done. Okay, so therefore, this is a typical beta angle problem. So please be careful while you are deciding whether to go for beta angle or not beta angle. The condition is the diagonal is inclined to both HP and VP, and the word appears should not be present in the problem statement. Okay, so we will going to start the problem how to show this projection, and we need to determine the beta angle also, how much what angle it will going to be there. Okay, so I will going to start this problem by just drawing it on a sketchboard. This you can practice those things parallel. Okay, so it is 30 millimeter side, 30 degrees to HP and 45 degrees to V. Okay, I will just start it now. So as usual, draw the XY line. I will go a little bit fast till the second position. It is remain same till the third position. Before you start the third position, so everything will remain same. So therefore, I will go a little bit fast now. Okay, so please follow it. X and this is Y. As usual, we have VP. So initial position. So since the diagonal of a square is inclined to both HP and VP, so we need to start the initial position by keeping the square lamina on HP on the corner. Okay. Therefore, we'll start drawing the square lamina of 30 millimeters side. Students, please practice these things. These are all very important. Okay, you should practice. Yeah. So I will go to give the name. So I'm going to start with this is A. This is B. This is C. So now, so in this problem, so I will go into, of course, this is a square of 30 millimeter side. So please construct the square of 30 millimeter side resting on the corner. You have to rest it on the corner. So here what I do is, since the diagonal has been inclined to both HP and VP, so it is make a practice of drawing the diagonal. Okay. So we're going to draw the diagonal over here, so which will be A to C. I will take corner resting here, and I will going to take A to C as one of the diagonal. So this is the true length. So you have to show only for, so the two diagonals will be there. One is A to C, another one is B to D. But A to C is the one which is parallel to both HP and VP, and hence you can see you can get the true length of the diagonal. So AC is the diagonal which is having a true length. Okay. So now I will going to project it for front view. So draw the projector lines. Okay. So give the annotations. So you can see this is A dash, and here we have B dash and D dash. B dash is visible in the front and D is not visible in the front. And at the end we have C dash. Give the annotations properly. Okay. Now join the line with a thick line because this is the front view. Okay. So in the front view, you look at here, the length of AC will be equal to the A dash and C dash because it is directly, it has been projected in the parallel to the XY line. So you are going to get A dash and C dash is equal to the same as that of the diagonal AC. Now in the second position, what we do here is the diagonal is inclined to HP at 30 degrees. So the diagonal is here in the front view, it is A dash and C dash, and we have to make that diagonal inclined to HP at 30 degrees. So now we are going to draw a line for 30 degrees. This is 30-degree line. Okay. So now I will going to tilt the lamina in such a way that the lamina should be rest on the corner A dash, and the diagonals AC, A dash and C dash is inclined to HP at 30 degrees. So how we can do? So we can draw A dash on the XY line over. We can show A dash as the on the XY line. Okay, and same thing, measure the distance of B dash and C dash and you can get the length. So I will go to directly, you can get the length of this line over here. So B dash and A dash will be, so you will go to get B dash and at this point, and similarly C dash will be here. Okay, so with the names over here, which is B dash and within the bracket B dash. Take the convenient distances from the compass and mark it, and at this point you will have C dash. Now join that line with a thick line from A dash to B dash. Okay, this is the what we are showing here is the diagonal is inclined to HP at 30 degrees. Okay. So in the second position, so we have shown that the diagonal is inclined to HP at 30 degrees. Now we will going to get the top view for the second position. Till here it remains same, no change. Only in the third position, we need to make the change. Okay. So use annotations over here. This is A. This is B. This is C. Okay. So join the lines with this line and complete the second position. Okay. So now, for our convenience, I will make the diagonal, which is given here, C. I will take that as diagonal C1. Okay. So AC is the true length and AC1 is the apparent length. When you look at here, when it is inclined, so it is looking the length of AC, the diagonal is diminished. Now, this diminished length of diagonal is inclined to VP at 45 degrees. So when this diminished is already the length is decreased and already inclined to HP, the same is inclined to VP, means it definitely does not incline to VP at 45 degrees. It will be inclined to VP at some other angle. So that angle we call it as beta. So now we need to determine that beta angle now. So how to construct, how to determine this beta angle? I will going to explain it now. So now start with what is the angle they have given? It is 45 degrees, right? So draw a line for 45 degrees. Either way you can construct. First you draw a line for 45 degrees. So how much angle they have given? For that you draw a line for 45 degrees. Okay. Then observe this. This is the one important where you are going to construct the beta angle over here. Yeah. So now what you do is first you draw the true length of the diagonal AC over this. So what I do is I will just mark the point for first. I will mark the point A and similarly C. The true length from the top view of the first position or initial position, you mark the points here, which is A, and this will be C. Okay. Now from C, you draw a locus line parallel to the XY. This is called locus of C. We'll explain once again. Draw the angle given to with respect to VP as 45 degree. Draw a line with respect to VP. Then measure the original diagonal, the true shape of true size of the diagonal. Mark that on the XY line on the 45-degree line, 45-degree line. From C, draw a locus line. Now you just observe here. Take a compass, measure AC1 from the second top view. Measure AC1, and now with A as a center here, with A as a center, with the radius equal to AC1, with radius equal to AC1, cut this locus line. Cut this locus line. So this will be C1 point. This point is C1. That's why I have taken different name there. Okay, so that it will be easy for us. This will be C1 for us. Now join AC1. Now join AC1. This is all. Okay. Now with respect to AC1, you have to construct this second position top view square over there. So please always remember this. So this is what you're supposed to do it. So now you extend this line. You extend this AC1 line. Okay. Then measure this angle. The angle what it is being inclined. So this angle will be the beta angle for it. This is beta angle. You have to measure the beta angle. How much it is? So this angle is supposed to measure. So you have to reproduce this and then this angle you have to measure. This will be what beta angle you are going to get for this problem will be 55 degrees. Beta angle we're going to get 55. So please measure it, we're going to get. Then with respect to AC1, you have to construct the. Okay. So how we can do, we'll go quickly now. My time is running out. So you have to construct this. Okay. So this is AC1 means this is AC1 is inclined in this way, and this will be B for you, and this is D for you. Okay. So now last 1 minute left out for me. I'm just to pause. Just project it to get the final. Okay. Now correspondingly you can mark the points over here. So A is here, B is going to get here, okay. Then C is here, okay. Then B is here, and okay, this is A dash, this is B dash, this is C dash,